Thank you for your interest in our paper, Region-Based Excavator Activity Analysis and Safety Monitoring System from Baidu Research. Operating excavators in a real-world environment can be challenging due to extreme conditions, such as multiple fatalities and injuries occur each year during excavations. Safety is one of the main requirements on construction sites. With the advance of deep learning and computer vision technology, our autonomous excavator system is assigned to load the waste disposal material into a designated area. While the system is capable of operating a whole 24-hour day without any human interventions. In this paper, we mainly address the issue of safety, where the excavator could potentially collide with the environment, human, or other construction machines. This system can also be generally applied to mine excavators and other construction scenes. This paper has three main contributions. First, we will develop a deep learning-based perception system for multi-class object detection, post-estimation, and action recognition of construction machines and human on construction sites. Second, we propose a novel excavator safety monitoring and the productivity analysis system based on the perception system. Last, we collect a dataset from our autonomous excavator system, including multi-class of objects in different lighting conditions with human annotations. Our network gets SOTA results on the AES and benchmark construction datasets. Our autonomous excavator system activity analysis and safety monitoring system pipeline, including video input, perception, monitoring, and analysis modules. The input to our system is surveillance camera video. The perception modules contains multi-class object detection, excavator post-estimation, working area segmentation, activity recognition, safety monitoring, and activity analysis. To begin with, I'm going to talk about data and perception module. First, working area are being segmented into digging and dumping areas. Then the detection method is used to identify construction machines and human in video frames. Second, the excavator is identified through post-estimation. Next, the action state of the tracked excavators is recognized with post-estimation, working area segmentation, and the action recognition method. Perception module including detection, post-estimation, area segmentation, and action recognition. Our detection method can detect multi-class construction machine, including excavator and loader, and human in real time. The detection of construction equipment is realized based on faster RCN. The architecture of faster RCN including backbone network to extract image features, region proposal generates network for generating region of interest, and the classification network for producing class scores and bounding box for objects. To remove duplicate bounding box, we apply soft NIMs to limit bounding box per object one. They collect an excavator dataset from our AES system from the waste disposal recycle scene. The dataset includes 2 hours of video in different lighting conditions and containing 2 types of construction equipment and human. We also design a labeling method for the fixed excavator as 10K points shown here in the figure. The segmentation network is based on ResNet. A digging area is defined as the waste recycling area which including various toxic materials. A dumping area is a designated area to dump waste. Based on excavator key posts and area segmentation results, we define excavator digging, swing, dumping action as follows. Here we labeled 100 clips of excavator videos with 3 actions: digging, dumping, and swinging. Then we implement learning-based action recognition module based on slow fast. Next, safety monitoring and activity analysis. Finally, construction safety is monitored based on perception results. Besides, the productivity of the excavator is calculated by the action recognition results. The autonomous excavator and the loader may have potential collision as figure shows. So it is important to detect potential collision since the loader is hard to know which state excavator is currently at from his wheel. The danger signal is sent when the autonomous excavator and the loader machines are both detected in the digging area. Besides, our system will send alert when human entering working sites. The productivity of the excavator is based on the action recognition results. The excavator's productivity can be calculated with the cycle time, and the bucket payload, as shown in equation. Since the bucket payload is given by the manufacturer, the target of the productivity calculation becomes to determine the cycle time of the excavator. For example, in a video, the excavator completes 14 working cycles in 15 minutes, and the average bucket full rate is 101%. So the excavation productivity is 64 in this scenario. The first step of circle time calculation is action recognition. The time for each circle is measured following the workflow in figure. After the action recognition, each video frame's excavator action is labeled. Then we record start and end frame of current action. So current action time equals to end frame minus start frame divided by frame per second of the video. Next, we decide which whether one cycle actions have ended, which including digging, swing, dumping, and swing in this scenario. If not, we will continue record frame of next action. Finally, we will sum up all action time to get cycle time. Here is some object detection results. We collect the things including excavation, human, and loaders. Here we demonstrate our system can detect multi-class objects in real time. Here is excavator detection and post-segmentation result on our AES dataset. Faster SN achieves 92% MAP and the simple baseline achieves 96% average precision. Action recognition results on AES and the UIUC dataset. The experimental results show that our action recognition approach based on slow fast outperforms the state-of-the-art approach on top one accuracy by about 6%. Here's the action recognition results on UIUC dataset. In this paper, we propose a safety monitor and activity analysis system based on detection, post-estimation, action recognition modules. Besides, we collect a dataset including multi-class of objects in different lightning conditions from our system. We also evaluate our method on a benchmark construction dataset and achieve sorted results. In the future, we will extend our perception modules to more construction machines in different scenarios. Thank you for your attention.